So, as always, the code for this question will be in the description, but if you want the explanation, you can continue watching this video. I think, especially for this one, it's a pretty tricky question. Me personally, I couldn't even get it even after 2 hours. So, basically, I couldn't even solve the first question after 2 hours, but let's put me aside. Let me explain to you what the question is. Basically, if you break it down to the bare bone essentials, what they're trying to tell you is, we'll give you a series of numbers like this. Something like this. And what is the length of this? It's 4, right? Should take a permutation of length 4, which means that 1, 2, 3, 4, these elements, and should arrange them in such a way that the difference between this number, just a second. So as I was saying, you'll be given these 4 numbers, not given, you should take these 4 numbers, given the length of this array is 4, and arrange them in such a way that, take note of this point, you should arrange them in such a way that the difference between the first, the array element and this permutation element, which gives you some final element, for example, in this case it's 5, there should be a distinct number of elements. That's it. The number of distinct elements, the difference is the number of elements which is the distinct sum of these, difference of these two should be distinct for as much as possible. Let me explain to you what that means. Basically is, given, for example, for this one it's 7, 5, and for this 4, this is 4, right? Okay, this is the best way to explain this thing is, if you look at this thing, the difference between 6 and 1 is 5. The difference between 7 and 2 is 5. 7 and 3 is 4, and 8 and 4 is 4. So the thing is, in this case, we have 2 elements in this array, which is 5 and 4. But we can make a combination, we can make a permutation such that we get this by changing these 2 elements, 2 and 1, and 4 and 3. If we do this now, what we'll get is, basically, we get 4, 6, 3, 5. Now there are 4 elements, 4 distinct elements in this case. Before we saw there are only 5, 4, 2 distinct elements. So your job here is to find this permutation, any one of them. There are multiple possibilities, which will give you the maximum number of distinct elements if you find out the difference between the 2 elements. See, initially, there are a lot of explanations for this one, but let's not talk about what I thought and how I made something wrong. Let's talk about the solution for this question, which is basically simple. See, for some values you will be given, it could be decreasing or increasing, anything. It could even be like this 1. It's not that it's in a sorted order or any other order, it's just random. The elements can be repeated also. So for example, in this case, if we remove 1, what you'll get is, we have 4 elements, so n is 4. So the numbers for this permutation will range from 1 to 4, and it should. So it will be from 1, 2, 3, 4. So these are the elements you should have in the permutation array. You can just sort them, you cannot add new elements to them. Now, see, the thing is, think about it properly and you'll get the answer for this one. See, that's the main point here. Even when I was writing the exam, just think about one thing very clearly, which is that, how do you get differences? No, seriously, think about how do you get different differences. Take an element, take another element, you'll get a difference. How can you make sure that these 2 elements, the difference of these 2 elements, should not give the same number as this one? You make sure that the difference between, for example, let me say it like this. See, the thing is, you take some number 6 and 1. You take this number 6 and 1, get the difference as 5, which means that the length difference between this, which is what difference basically means, is 5. Say 5, 6 and, we'll do it like this, 5 and 2. Difference between this So how much? 3. See, or take another number. Let me illustrate it with another example. 6 and 0, maybe. That's not a good example, but let me do it like this. 7 and 1. Difference is great. It will give us 6. You look at these things properly and you'll get one thing. In order to have a difference which is different, in this case, this difference should be higher or lower. That's it. See, I know. It doesn't make sense, but think about this properly. In order to have the difference which is different, either this number or this number should be different. Or in another way, we should say that the length of this arrow should be smaller or bigger than this length. In this case, if you forget about this one is bigger than this one. Now that's the first point. In order to have a different differences, the length should be different. Now, don't you think it's the best thing to have the lens in such a way, the different lens in such a way that has a nice order to it? Like for example, in this case, don't you think it would be better if it was like something like this? For example, if it's 6, 5, 4, 3, the difference was 1. 1, 2, and 3. 4. In this case it won't work actually, but still it can work. See, what I'm trying to do here is, so basically in this case I decrease the length of this difference by 1 for each case. In this case it's 1. So if we here will get 5, here we'll get 4, sorry, 3, sorry, actually I will get 3, sorry, 3. 4 minus 3 will be 1 and 3 minus 4 will be minus 1. Yes, minus 1 also counts as a difference. So basically, if you look at this thing carefully, see, the thing is, I can just tell it to you completely nicely and in a well explained way, but I want you to get to the answer yourself. See, what you basically have to think about is to have different differences, right? You can either do this thing by changing. For example, you take this number, you take these numbers, and for the first one, what you'll do is 1, 2, 3, 4. That's the permutation you have because there are 4 elements here. What you'll basically do is have the numbers in such a way that the biggest value will have the smallest number, and the second biggest value will have the second smallest number, and so on. So what it does is the difference will be decreasing, but the point is it will be decreasing, and once it's decreasing, either non-increasing. What do you say? Yeah, non-increasing. So basically, it won't increase at all. With this one, if you think about it properly, what it does is, since it is non-increasing order, not completely decreasing. If it is completely decreasing, then we will have like every element will be distinct. But in this case, since it's non-increasing, the number of distinct elements in this possible combination, the numbers you'll get, which is this, will always be maximum, because it's still better than if you arrange it in such a way that there are two numbers which are similar. In this case, this is the maximum possibility that will have, like the maximum number of elements. For in this case, if this was 1, if it was 1, it's not 1, then this would have been the maximum possible case scenario, which it won't happen in any scenario as far as I know, because in this case it will only happen if this number was equal and this number should also be equal in that case. But since it won't happen, hopefully, see, I haven't really thought about the edge case. Let's look at this thing properly. Yeah, so after a lot of analysis and a lot of thinking, I realized that it's not even possible for you to get this combination like 1 1. This you won't even have similar elements. This won't be non-increasing. This is strictly decreasing. This difference you will get with this will always strictly be decreasing. I'll tell you why. Because see, one question you can have is, we can start from here, right? We can start 1 2 3 4, and the difference will be, what will happen in this case? If you look at this thing, basically 1 minus 3 is 2, and 4 minus 2 is 2, and 3 minus 5 is 2, and 6 minus 4 is 2. So you will get that condition. But in this case, if you reverse it, we start with this, the highest number with the lowest number here. the difference you'll get here will be strictly decreasing. Strictly decreasing. So it's not about the maximum possible combination. No, every single element, every single difference you get will be distinct, and it will be strictly decreasing too. So this is one thing. Okay, now we understood that we should arrange it in such a way that the highest number has the lowest permutation. But it's not sorted in, right? In this case, I sorted it, but it's not actually in sorted order. In the example, for example, I've given you. See the example, what will get is, let's take this one. Now, first of all, we know the highest number is 7, so we'll start with 1 here, and here it's 6, so it will be 2, 4, 3, then 2, 4, and 5. That's the order, we know that. But we can't search each and every time what the maximum element is and assign it the value. It will take us n square, the worst case scenario. So what we can do is we can do 2 of n log n. Basically, instead of n square, you can do 2 of n log n time complexity. I'll tell you why. Which basically means we'll sort this array 2 times. Not exactly, but I'll explain to you what it means. So in this case, first we have this number. Now we need to first sort it in such a way that we can still maintain its indices, right? So for that, what we'll do is we'll make a 2D array. Basically, like we'll make a 2D array list such that the indices will be maintained. So 1, 2, 3, 4, 5. Now this is an array. For example, in this case, this is a list or 2D list with this as the element. Each of the element is this 6, 1. And the second element 7, 2. Such that we have this list. Now, after we sort this, what will we get? We'll get, let me write it down properly. So 7. No, sorted means it will start from again. 1, 3, 4, 6, 7. Right. And for 1 we'll have 4. For 3 we'll have 3. For 4 we'll have 5. For 6 we'll have 1, and for 7 we'll have 2. So we have this. This is the final thing we get. I shifted the order, sorry for that. This is the actual order, and this is the one. I didn't shift anything, sorry. So we now have the indices sorted, but this is in sorted order. This is what we want, and this is what we need later on. But look at this now. You have 1, 3, 4, 6, 7, right? So as always, what I told you was we'll need to have the difference, right? So for 7 it should be 1. So as obviously we'll append another number to it. Basically means that, let me write it down up here. Sorry for the inconvenience. We'll have 5, 4, 3, 2, 1. This is our array that we have initially, and we sorted it. This is the indices of the elements before sorting it, and this is a permutation in which we need to be. This is the pair for the particular element of the array that this number of permutation array should have for the elements of the difference of these numbers to be maximum, which is 5 in this case. We'll get 5 distinct elements. So now what we'll do is we have this one. This is basically what we need. This is the numbers we need, and we need it sort in the locations in which this array was previously. And for that, we need this array. This array we have the location, which means the position of each and every element, the actual position before sorting. So now what we'll do is we'll forget about this one. We have our answer. We basically need to sort this one properly. What we'll do is we'll sort this array elements again. This part will sort it with this 2D array, which basically means that we'll again come back to 1, 2, 3, 4, 5. 1 will have 2, 2 will have 1, 3 will have 4, and 4 will have 5, and 5 will have 5 will have when I am getting confused. 1 will have 2, 2 will have 1, 3 will have 4, 4 will have 5, I will have 3. So with this one, we basically have our answer, which is the permutation combination in which the array should be such that the difference, the number of distinct elements we'll get from the difference is distinct, which is 2, 1, 4, 5, 3. See, the thing is, for this one, the code explanation is simple. Take an array, take a 2D array and append the actual array and the index. Basically you take a variable called count in the code. If you look at it, you'll get it. Variable called count, and you append one count like 1, 2, 3, 4, 5 for each and every element, and then you sort the upper element. In Python, you have a function in which you can sort a 2D list based on whatever row you take. So you take the first row, which is the array, and you sort it, and you get this below one that we mentioned, and then you append another values, which is like the 5, 4, 3, 2, 1, and then you sort the indices, which is basically what you'll get is the previous positions of the previous array value. Okay, I'm trying to explain it in the best way possible. Hope you're understanding. First you sort the elements and you have the indices also sorted. Not sorted, indices also jumbled. Now you append 5, 4, 3, 2, 1. Then what you do is you'll sort the indices now. And forget about this one. You'll sort the indices and you'll get the positions in which this permutation value should be such that the individual differences are different. And then you just print it out and you get the answer. The thing is, that is the thing that you're supposed to think of. If you thought of that one thing, the one key point, which is that first thing I told you is the difference should be different at all time. And for that, the lower you go, the more decreasing you get, which means that for the highest value, if you get the lowest number, the difference will be the highest. And for subsequent numbers, you keep decreasing the value. It will always be different. You think about it properly, you'll understand what I'm trying to say. So that's all for this question. This is an A question, but it's still kind of tricky. And yeah, I think I'll post the next video when I make the next. That's all the next question actually. So yeah, thank you.